Hey class, I'm Joe, and I'm going to be talking about chapter 2 from our book Zero. This chapter is called Nothing Comes of Nothing. So the chapter starts off talking about Greek number philosophy. This was heavily influenced by the Egyptians who came right before. The Egyptians didn't see a lot of use for mathematics or numbers except for to keep track of money and to keep track of land. And a fun fact is that geometry actually means measure of land. So that came from the Egyptians because that's what geometry is originally used for, keeping track of whose land was whose. When the Greeks came around, they used a lot of this ideas because Greek number philosophy was heavily based off of shapes. They saw that numbers and shapes were interchangeable. And we can still see that in today's mathematics. For example, when we talk about square numbers, as we can see down at the bottom, or triangular numbers right above it. These are numbers that can easily be seen in the shapes, and so they have an added importance. And this is largely because of the Greeks. The greatest Greek mathematicians, or at least some of them, were the Pythagoreans and Pythagoras. This was a kind of math cult. They came up with crazy ideas together, and they were very secretive. And the book talks a little bit about some of the people who they killed because they were threatening to reveal these mathematical secrets that would mess up their philosophy. The key Pythagorean philosophy was that all is number, that every thing in the universe can be represented by numbers, shapes, and ratios. The thing we think about when we hear Pythagorean is the Pythagorean theorem from geometry. But the book says actually that's not technically the Pythagoreans' belief in that, or invention, in that it had been discovered years and years and years and years before. And there are actually hundreds and hundreds of ways to prove the Pythagorean theorem. So that's actually very believable. One thing that Pythagoras did do was invent the musical scale. This is a deeply mathematical thing. A lot of mathematicians are also musicians because the musical scale uses modular arithmetic. Basically that after 12 half steps, when you're playing a musical instrument, you get back to the note that you were at before, just at an octave higher. How can zero fit into this philosophy that all is shape? What would a square of area zero look like? It's hard to imagine, and because of that, zero had no room in the Greek number philosophy. It was highly rejected. Okay. The Pythagorean model of the planets looked like this to the side. Earth was at the center of the universe, and as we moved outward, they believed that there were different spheres for the different planets. Pythagoras, like we talked about, believed in the musical scale. So they thought that as the spheres were rotating and moving and changing, they were making a beautiful musical harmony that he called the harmony of the spheres. So again, this is a very centered universe. It doesn't involve infinity, and it definitely does not involve zero. Another belief of the Pythagoreans was in the golden ratio. This was the number that they thought was the most beautiful, the ratio that they thought was the most beautiful. And we can see it in this corner. We can get it by dividing a line such that the ratio of the small part to the large part is the same as the ratio of the large part to the whole. So if our large part is A and our small part is B, then A over B is equal to A plus B over A. And this is equal to 1.618 on and on and on, which is actually an irrational number. We'll talk about that in a second. The book talked a little bit about where the golden ratio is seen in nature. And I remember in fourth grade or fifth grade, my teacher talked to me about that. Maybe some of yours have too. This is actually kind of not true. The golden ratio is seen in a lot of architecture and a lot of artwork because it's a human invention. But in nature, I mean, you can see it in these pictures, but also these are very individual pictures. And my face, it's not perfectly shaped. So sometimes they'll tell you the length of your forefinger is the same as the length of your nose to your forehead. And this maybe is sometimes true, but largely the golden ratio is just a man-made invention, not something seen in nature. The Pythagoreans had a very dark secret that would actually kind of destroy their whole philosophy, that all is ratio, that everything can be seen rationally. And that is that irrational numbers exist. The Pythagoreans knew that irrational numbers exist. And it can easily be seen in over here in a square. An irrational number is a number that can be written in the form a over b. So 2 is a rational number because it can be written as 2 over 1. And a zillion is a rational number because it can be a zillion over 1. But we can see it in a square. If we were to take a square where each side is equal to length 1, there is no way we can find an even beautiful number that is equal to the diagonal of this square because it's an irrational number and it's equal to the square root of 2. The Pythagoreans knew this and they kept it a secret. It would destroy their whole philosophy. One of their members actually did reveal this to people and he was drowned. They killed him. So it was the Pythagoreans, like I talked about before, were kind of a cult and they were willing to kill for their secrets. Now, so far we've talked a lot about how zero have not been included, but Zeno's paradox was one of those beliefs and ideas that really changed the world and help people invent infinity and zero. Zeno's paradox was that nothing can ever move. And it was modeled by Achilles, who was one of the great warriors and athletes of their time, saying, can Achilles beat a tortoise in a race if the tortoise has a head start? So say that Achilles can run twice as fast as the tortoise, and the tortoise starts off 1 meter ahead of Achilles. After 1 second, Achilles has already made it to the point where the tortoise was the second before, but the tortoise has made it half the distance further than where he's at. Well, half a second later, Achilles is at where the tortoise was at, as we can see in the second thing, but the tortoise has moved, so now he's 1/4 of a meter ahead of Achilles. And we can continue this on and on and on. Achilles moving 1/4, and then 1/8, and then 1/16 of a meter. And every time the tortoise will have moved just a little bit ahead so that Achilles, for all of time, will never be able to catch up with the tortoise. Now, obviously that's not true because we can move across the room and we can see Usain Bolt beating people who are much slower than he is. So, but mathematically, it was very, very hard to disprove Zeno's paradox because in order to disprove it, you need to use the ideas of infinite limits, which we've all heard about in our calculus class. It is totally impossible to disprove Zeno's paradox without the use of either zero or infinity. So another Greek that was very, very important was Aristotle. And Aristotle had a very similar belief to Pythagoras in the model of the universe, that the Earth was at the center, and as we went outward, there were different spheres. However, since there was no belief in infinity, there had to have been a last sphere. And this idea had a huge implication. It made room for God, because in the Bible, it says that the universe is a sphere, and at the outside are the stars, the lights that poke in, and then as we get inside, we get to the center of the world, which is the universe. If all this stuff is not infinite, something had to have created it, and so there had to have been the creator, God. There's one big hole in this argument that there is no infinity and that there's no zero, if you believe in the Aristotelian cosmos, which is that what existed before creation? If nothing existed before creation, then there have to have been a time zero, because otherwise they would have just started out of it started out of something. But if there was something that had to go back forever and ever and ever. So basically, if the universe has gone on forever, then that is a belief in infinity. And if it started at a point, then that is a belief in zero. So that is the big hole in the Aristotelian cosmos. Along after them came Archimedes. Archimedes is one of the greatest mathematicians to ever live. And he has, in a lot of my math classes, my professors will still kind of talk about Archimedes as one of the great inspirations for mathematicians. One of his cool ideas was he thought of using displacement to measure gold. There was no way to tell if gold was pure. And so he thought, oh, well, if we drop it into a full thing of water and we can measure the amount of water that was displaced, and then we can determine if the gold was pure or not. Archimedes also toyed with the idea of infinity and infinite limits. At the time, there was no way to measure the area under a parabola. And as we can see in this picture, Archimedes said we can use triangles because we totally know how to measure the area of triangles. So we can make a big triangle to touch all the sides of the parabola. And then with that space that's left over, we can make smaller triangles and then smaller triangles and then smaller triangles. And if we add them up and get to really, really tiny triangles, eventually the area of the triangle will be so tiny, it'll be so close to zero, it'll be negligible. And using that, we can get a very, very close area of a parabola. So anyone who's taken calculus can see how close this is to like Riemann sums. And so Archimedes really was way ahead of his time, thinking of calculus and infinity and infinite limits. The last part that this chapter talks about is how zero works in years. Back then, Christian monks needed math to determine what day Easter lies on, because Easter is on a different day every year. And this one monk, Dionysius Exiguus, invented AD. He calculated the year of Jesus' death and said, okay, well, we can say 180, 280, 380 to name the years. This also kind of comes with the problem, though. What happens before AD? Was there a 0 year? Because again, at this point, 0 was not an idea yet. So what the monks did was they said, okay, well, we just go straight from 1 BC to 1 AD. But that has to be wrong. Imagine a child born on January 1st, 2 BC. It's very easy to say, okay, on 2 BC, he was, well, we're not going to say 0. We'll say at 1 BC, he was 1. Then at 1 AD, he's 2, 283, 384, 480, he's 5 years old. And yet, if we do our calculation, 4 AD minus negative 2 BC, we would get the child was 6 years old. So this is the clear hole in this argument, which is why it needs 0. Okay. That's all. Have a good day, everybody.